Okay, here we go. Identify the range of this function. Well, whenever they tell you to identify the range, you immediately focus in on what? The y values. Now, you'll notice in all of your choices that there are two numbers with y's in between them. You have to decide which numbers are right first, and that will eliminate two of the choices. Now, y values are up and down. Which way do you go first? Down. Remember, the y values, you always list the lowest y value first. And isn't this the lowest part of this graph? And what is its y value? -5. And then isn't this the highest part of the graph? What is its y value? 9. So we have now discovered that the range goes from -5 up to +9, which obviously eliminates A and B because those are the wrong numbers. Those would have been the right numbers had they been asking for the domain, because the domain does go from 2 to 8. Okay, from left to right it goes from 2 to 8, but from the lowest point to the highest point it's -5 up to 9. Now you have to look at them and see that the only difference between these two answer choices are the signs. In C, neither of the less than signs have equal to bars. In D, they have equal to bars. Do we need them or do we not? We do. Okay, because there is a point right here that has a y value of 9. Okay, there is a y value equal to 9. So there would need to be an equal to bar. And you could plot a point right here and its y value would equal -5. You would only have a need for the less than signs without equal to bars if we'd have been dealing with like an open circle. Okay? Okay, now we're going to continue the lesson from yesterday. So go ahead and turn your packet to where we left off yesterday. Okay, so in Algebra 1, you learn about 6 functions. These functions are linear functions, quadratic functions, cubic functions, exponential functions, square root functions, and absolute value functions. Linear functions were all covered in Unit 2. That's the one we just finished. Okay, we learned how to graph a linear function. We learned how to solve a linear function. We learned about arithmetic sequences, which are linear functions. Like if you put an arithmetic sequence on a graph, it would make a straight line. Okay? And now in Unit 3, we're learning about quadratic functions. Okay? We all remember that in a linear function, it's in the form y equals mx plus b, where m is the slope, and that controls how steep the line is. Okay? Sometimes if the slope is a large number, it may be like a very steep line. If the slope is a small number, the line may not be steep at all. Okay? The b is the y-intercept. Okay? And that is where the line cuts through the y-axis. Now, your most basic of all lines is y equals x. Okay? That function is also known as the parent function for linear functions. Now, over here you'll see that instead of y equals x, they wrote f of x equals x, which is the same thing. Now, the blue line that's already been graphed is y equals x, because think about it. Doesn't y equals x have a slope of 1, because there's an understood 1 there, and it has a y-intercept of 0, because there's an understood plus 0? That's why it started at 0, and then from there it went up 1, right 1, up 1, right 1. So this is the parent function for linear functions. It's like the original linear function. Now, in Unit 2, the test we just tested over, we learned how to write the domain and range of linear functions. We learned how to locate the x-intercept and y-intercept. We didn't really talk about roots. You'll talk more about that in Algebra 2. We talked about end behavior, and then we didn't really talk about those. Those are things you'll get more into in Algebra 2. Now in Unit 3, we're moving into quadratic functions, which also have a parent function. Every function has a parent function. It's like the starting function. Now, the form for this is the standard form for a quadratic function. It's ax squared plus bx plus c. But the parent function is just y equals x squared. So in that case, the b would have been 0, the c would have been 0, and the a would have been an understood 1. Okay, this is what the parent function looks like. It starts at 0, 0, and then it goes up. Okay, now in this unit, we will be learning about the domain and range, the x and y intercepts, and the end behavior of quadratic functions. Okay, and then when we move to unit 4, we will learn about cubic, or maybe exponential. I'm not sure which one's next, but we'll be learning about one of those. Okay, so you're kind of starting to see the big picture a little bit more. Okay, so today let's continue with quadratic functions, and we're on the page where it says the absolute value of a is less than 1, right? So this one. Okay, so yesterday we filled in this one, didn't we? It was -2, -0.5, 0, -0.5, and -2. We filled in that one. Did we graph it? Okay, so now let's fill in the table for this one. Okay, when you replace this x with a -2 and you type in -2 times -2 squared, what do you get? A -8 is correct. Okay, what about when you replace the x with a -1, what do you get? 0, 1, -2, and 2, -8. Now, see how when I had a -2, it produced a -8, and when I had a +2, it produced a -8? And in the same sense, a -1 and a +1 both produce a -2? That happens because of the squared. That's what makes it a parabola. -2 squared is going to give you a +4. And then when you multiply by -2, you're going to get -8. +2 squared will give you a 4. And when you multiply it by -2, you'll get a -8. So no matter which way we go, left 2 or right 2, we're going to go down 8 on both sides, which is what gives it that U shape. Okay, so now let's graph these points. -2a is left 2, down 8. -1, -2 is left 1, down 2. 0, 0 is just at the origin. 1, -2 is right 1, down 2. And 2, -8 is right 2, down 8. When you connect them, the most obvious difference between this one and the parent function that's already graphed above is what? That's the most obvious to you? Well, I mean, that is correct, but I was going for upside down is the most obvious. I didn't know if some of y'all would see that it's skinnier, but it is also skinnier. Okay, now, the reason it's upside down is because of that negative beside the 2. Okay, if the a value is negative, it's going to reflect it. It's going to be upside down. The reason it got a little bit skinnier is because the a value is a 2. And if your a value is larger than 1, it's going to be a vertical stretch, which makes the parabola skinnier. Okay, so down here, did we write vertical shrink on the first line yesterday? Okay, well this one has a vertical shrink, the pink one, which I didn't graph today because it was graphed yesterday. It had a vertical shrink and a reflection. Then the one that I just did in green has a vertical stretch and a reflection. Okay, once you've written that, go ahead. Well, you don't have to turn a page. Yours is on the same page. Now we're going to talk about what happens when you add a number to the side, out to the side of x squared. Everybody got it? Okay, so now look, we're going to talk about if you take the parent function, y equals x squared, and you add a number to it. Okay, the parent function's already been graphed, and the reason it starts at 0, 0 is because with the parent function, it's just y equals x squared. Nothing has been added to it. Okay? Now we're going to figure out what happens to it if something is added to it. Okay, starting with this one, y equals x squared plus 2. First, let's fill in the y values by plugging in the given x value, so go ahead and do that. Okay, when you plugged in a negative 2, squared it, and then added 2, what did you get? Okay, that's correct. What about a negative 1? I got 3. What about a 0? 2, and then... Okay, look guys, if you plug in a 0 and you square it, yeah, you get 0, but then when you add 2 to that 0, you have 2. What about when you plug in a 1? Oh yes, sorry, 3. And then what about when you plug in a 2? 6. Okay, so now I'm going to graph those 5 points, starting with negative 2, 6, so it would be left 2 up 6. And then negative 1, 3 would be left 1 up 3. 0, 2 would just be up 2. 1, 3 would be right 1 up 1, 2, 3. And then 2, 6 is right 2 up 6. Okay, so when you connect these, what differences do you see in this parabola from the parent function that's already been graphed on your paper? It doesn't have a vertex of 0. Where is the vertex now? 2. And what do you think caused the vertex to shift up 2 units? The plus 2. Now, nobody said it in here, but some people always like to try to say that this one got skinnier. But it did not. It may appear that way because of it being shifted up, but think about it. Had you, just say you added in a negative 3 to your chart and a positive 3 to your chart, what would negative 3 and positive 3 give you if you plugged it in? $11. It would give you an 11 for both. So think about it. If you went left 3, 1, 2, 3, up 11, wouldn't you pretty much land on the other parabola? And if you went right 3 and then up 11, you would pretty much land on the parabola. So it's the same width. It didn't get skinnier or wider. The only thing that changed was the vertex went up 2. The entire parabola shifted up 2 units. Nothing else changed about it. Okay, so that is a upward vertical translation. So write that down here, upward vertical translation. Okay, and that occurs because we added a number to the x squared. Okay, now let's look at the other one. And I found these notes online and I wasn't able to edit them. I would have had I been able to because I don't really like what she did here. Do we ever leave a plus a negative? No. I mean, I get why she did it because she's saying what happens when you add something to the x squared, and so she's adding a negative number, but really you're subtracting the 2, correct? So it's x squared minus 2. Okay? Now, when you plug in negative 2, square it, and minus 2, what do you get? I got 2. Because negative 2 squared is 4, and 4 minus 2 is 2. When you plug in a negative 1 squared and you minus 2 from it, what do you get? Negative 1. When you plug in 0, what do you get? And then when you plug in 1, won't that be the same as the other one? And when you plug in 2, you'll get 2 again like you did up there. Okay, so now we're going to plot these points. Negative 2, comma 2 would be left 2, up 2. And then negative 1 would be left 1, down 1. 0, negative 2 would just be down 2. 1, negative 1 would be right 1, down 1. And then 2, 2 would be right 2, up 2. Okay, and then when you connect them, what do you see that has happened? It just went down. It's not any wider, even though sometimes it may appear to be. It's not. You can just see more of it. It just went down 2. Okay, so it was a downward vertical translation that occurred because we subtracted a number from the x squared, which is the same as adding a negative number, right? Okay, everybody got that page? Okay, now go to the next page. Okay, properties of the graph. The graph, well first, before we do it, let's go ahead and recreate the parent function on this graph. So remember, the parent function is y equals x squared. Its vertex is at 0, 0. And then think about it. If you plugged in a -1 or a +1 into this, both of them are going to give you what? So you're going to have a point at -1, +1, and +1, +1. If you plugged in either a -2 or a +2, you're going to get what? 4. So if you go left 2, you'll need to go up 4, and if you go right 2, you'll need to go up 4. If you plugged in either a -3 or a +3, they're both going to give you 9. So when you go left 3, you got to go up 9, or when you go right 3, you have to go up 9. And so that is the parent function of a quadratic function. Okay, the graph of ax squared plus bx plus c is a parabola. Kind of like the graph of y equals mx plus b is a, nobody knows? Right, a line. Okay, if your a value is greater than 0, then the parabola will open up. It'll look like this. If the absolute value of a, so like if you take the negative off of the a, then and the a value is still greater than 1, the graph is narrower, and that's a vertical stretch. Remember, when it gets skinnier, it's because it got stretched up. Okay, if a is less than 0, the parabola opens down, so it would look like this. And if the absolute value of a is less than 1, the graph is wider, which is a vertical shrink. The parabola has an axis of symmetry, which is just the line that cuts the parabola in half straight down its vertex. And there is an equation for that, but we're not going to worry about that right now. The parabola has a vertex and the y-coordinate of the vertex is the minimum value if the parabola opens up, which is when a is greater than 0. Okay, so if a is greater than 0, the parabola will open up and the vertex will be at the bottom, so a minimum value. It has a maximum value if the parabola is upside down, because in that case the vertex would be at the top, right? And then the parabola has a y-intercept of c. The point 0c is on the parabola. Okay, now over to the right. Do you see those two tables with questions? I want you to try those by yourself. You're going to fill them in. Then you're going to put them on the graph. They're both going to go on this graph. And then you're going to answer those questions about them. Okay, I'll give you about 5 minutes and then I'll go over them. Yes, both of them. Does everybody know how to type those in the calculator? If you don't, you need to come up during this time and ask for help. Okay, for table number 1, the one that's y equals -1/4 x squared plus 2x plus 1, what did you get for the y values? Hold on, let me write them in a different color. That way it'll match up with my parabola. Okay, -4, 1, Okay, before even graphing it, you should be able to answer some of these questions. The first question says, does the parabola open up or down? Without even putting it on the graph, can you tell me if it opens up or down? How do you know that? Right, the a value, which is the number beside x squared, is a negative number. If your a value is negative, your parabola will open down. Okay, now for the axis of symmetry, you're going to need to see a graph and draw that line before you can tell me what the axis of symmetry equation is. Same thing with the vertex. You can go ahead and tell me whether the vertex is going to be a max or min before you ever put it on the graph. If it opens down, will the vertex be the highest point on the parabola or the lowest point? The highest. So the vertex will be a maximum value. Okay, and then you can tell me whether it's going to be a vertical stretch or shrink by just looking at the a value. What is the a value? Right, and what's the absolute value of negative 1/4? Just 1/4. Is 1/4 less than 1 or greater than 1? Less than 1. If your a value is less than 1, which in this case it is, 1/4 is less than 1, then it is a vertical shrink. Okay, anytime that the a value is less than 1, once you take the negative off of it, then it's a vertical shrink. Okay, now let's put it on the graph so that we can determine the equation for the axis of symmetry and the vertex. So the first point is -2, -4, so that would be left 2, down 4. And then the next point is 0, 1, so that would just be up 1. And then 4, 5 would be right 1, 2, 3, 4, up 1, 2, 3, 4, 5. 8, 1 is right 8, up 1. And then 10, -4 is right 10, down 4. Okay, now that it's on the paper, you can definitely see that it opens downward. Oops, I missed that point. And you can definitely see that it's wider. There's a vertical shrink that's occurred because the a value was a number less than 1. Now let's do the line of symmetry and the vertex. Okay, wouldn't the line of symmetry have to cut through right here to cut it in half, two symmetrical parts? What is the equation of that line? Where does that line cut through the x-axis? So the equation of that line is x equals 4. It's a vertical line, which is why it starts with x equals instead of y equals, and then it cuts through at 4. Okay, so the axis of symmetry is x equals 4. And now they want the coordinates for the vertex. Where is the vertex? No, the vertex, that's the y-intercept of the parabola, but the vertex is 4, 5, right? And it's definitely the maximum point because it's the highest point. Okay, now let's do the other one, and I'll do it in green. What did you get for these y values? Okay? Before you even put it on the paper, how can you tell me whether it's going to open up or down? By the a value. What is the a value? It's a positive 4. 4 is not as important. Positive is what's important. If the a value is positive, then that means it will open up. Okay, we can't really do axis of symmetry yet. Is the vertex going to be a min or a max since it opens up? A minimum. The vertex will be at the lowest point. And then, since it's 4, is that going to cause a vertical shrink or stretch? Stretch. Okay? When your a value is greater than 1, which 4 is greater than 1, that's going to cause a stretch. And think about it. Remember with slope, the larger your m value got, the steeper the line got? The larger your a value gets, the more stretched out and skinnier the parabola gets. Okay, now let's graph it so that we can write the axis of symmetry's equation and the vertex. Okay, the first point is -0.59, so that would be left half a box and then up 9. So like right there. 0, 4 would just be up 4. 1, 0 would just be right 1. 2, 4 would be right 2, up 4. And then 2.59 would be right 2.5, up 9. So this one definitely opens up because it had a positive A value. It's definitely skinnier because its A value was 4. Where would I need to draw in the axis of symmetry? X equals 1. Okay, it would be a line cutting through the x-axis at 1. And where is this vertex? 1, 0. Okay, so the axis of symmetry was x equals 1, and then the vertex was 1, 0, and that was the minimum point on the parabola. Okay, we're done. You can switch out. There's no homework.